Welcome, viewers. In this session, we're going to look at the Cobb Dauglas function and its application. Cobb Dauglas function is an important concept in economics that describes the relationship between the inputs and outputs of a production process. So the function is named after economists Charles Cobb and Paul Dauglas, who first introduced these functions in the 1920s. The Cobb Dauglas function is used to model the relationship between the inputs and outputs of a production process. The equation takes the form f of x1, x2 up to xn is equals to a times x raised to power b1 times x2 raised to power b2 up to xn raised to power bn, where the function f is the output, a is a constant, x1, x2, x3 up to xn are the inputs of the production process, and b1, b2 up to bn represent the elasticity of the output with respect to each input. These quantities or these constants are all positive and their sum is always equals to 1. So the Cobb Dauglas function has a number of important properties that make it useful for modeling the production process. For example, it exhibits a constant returns to scale, which means that if all inputs are multiplied by a constant factor, then the output will also be multiplied by that same factor. So this property makes the function easy to work with and allows for the straightforward analysis of the effects of changes in input levels. In general, the Cobb Dauglas function is used to model production processes and analyze the effect of changes in the input levels on output. And its properties make it useful tool for economists and other researchers studying the behavior of farms and industries. Let's take an example. The Cobb Dauglas function of a new product is given us by f of xy is equals to 20 times the square root of xy, where x is the number of units of labor, y is the number of units of capital required to produce f of xy units of the product. So each unit of labor costs $40 and each unit of capital costs $120. You're given that $300,000 has been budgeted for the production of the product. So the problem is to determine how this money should be allocated in order to maximize production. And part B, what is the maximum production? And then we need to find the marginal productivity of money and estimate the increase in production when an addition of $40,000 becomes available. So we say that here we have some two products or two items that where we incur money. We have the labor and capital. I'll denote them by L and C. Each unit of labor costs $40 and each unit of capital costs $120. And we have X units of labor and Y units of capital. So you see the total cost that is to be incurred here will be 40X on labor and 120Y on capital. So if we were to look at now the total cost, we get 40X plus 120Y. But this one must not exceed the amount of money that is being budgeted for. The budget is $300,000. So this should be equals to 300,000. So this is now our constraint. So the objective function, the function f that we need to maximize, is given by 20 times the square root of xy. And now we have the constraint. So that our problem can be stated as maximize f, which is 20 times the square root of xy, subject to 40x plus 120y is equals to 300. So our function here, we can also write it as 20 x raised to power half, y raised to power half, or y raised to power 0.5, x raised to power 0.5. Then we set up, we form our Lagrangian. Then we differentiate L partially with respect to x and partially with respect to y. So remember, when you are differentiating x raised to power 0.5, then you would get 0.5 x raised to power 0.5 minus 1, which will be a half x raised to power negative 0.5. So when we differentiate this partially with respect to x, see that differentiating x will give us this x power half, which we multiply by 20 y raised to power 0.5, so that when we multiply this and this, we get 10 x raised to power negative 0.5, y raised to power 0.5. The next time here we get 40 lambda. Remember, the other terms are to be assumed to be a constant. Similarly, we differentiate L partially with respect to y to get this. Next, we equate this to 0, these two derivatives to 0. Plus, of course, we have the constraint function, so we have the equations now. So from the first equation here, we can make lambda the subject, get minus 1 over 4. See that we can get 40 lambda is equals to minus 10 y raised to power half divided by x raised to power half. Or even this is minus 10 times the square root of y over x. Then we divide the row by 40 so that we get lambda is equals to 1 over 4 negative times the square root of y over x. Similarly, from the second equation here, we can make lambda the subject to get minus 1 over 10, the square root of x over y. So if we now equate this and this, we can get 1 over minus 1 over 4 root y over x is minus 1 over 12 root x over y, which we simplify. See that we can multiply through by minus 12 to get this. Then if we square both sides and simplify, we can get x is equals to 3y. So once we have that, we substitute into the third equation, x is equals to 3y, so that we get an equation in y only, and then we solve to get the value of y is 1250, and then x is 3y, so we substitute, we get that. So the maximum production will be given by, remember, our function f x comma y was 20 times the square root of x times y. So we can find the optimal production or the maximum production by substituting x is that 750 and y is 1250 to get that. Now, the value of lambda that we have here, either from this equation or this one, we call it the marginal productivity of money. And this one gives the approximate increase in production for each additional unit of money spent on production. So in this case, the marginal productivity of money, which will now be the modulus or the absolute value of lambda, we can substitute the values of x and y, we get 0.14434. So this will give the approximate increase in production when we add each unit, when we have an additional unit of money. So if for example, in this question, you are told that an additional capital of 40,000 becomes available, so each unit of money spent will increase production by this factor. So if we want to determine the increase in production, we just multiply the amount of money the amount of capital being added by the marginal productivity of money. So increase in production is equals to the marginal productivity of money times the capital increase. In this case, we get 5,774 units. So basically that is how we can determine that. Now, since I will share with you these notes, I want you to go through this example number 2, since it's done. You go through it, and also number 3, they follow the same, you can follow through the same way and work out. So make sure you work out those and ensure you can get the results, the same results we have there. Thank you for watching.